the brain is a large, delicate mass of neural tissue. Like I said, it's all nooks and crannies, both on the inside of the brain, the ventricles, and also around the outside of the brain. It's all covered with cerebrospinal fluid. Now, what that really means is that your brain is just literally floating in this cavity. It's surrounded by water on the outside, and it's got water in the middle. Both tend to act as cushioning devices. If you get somebody to hit you in the head and jostle your brain around, it's just one more very important part of your protective mechanisms to protect your brain. You watched Monday Night Football last night or Sunday Night Football, you notice they hauled a couple of guys off to undergo the concussion protocol, they call it. Well, it would be really nice if those guys had a lot more water around their brain to help cushion their brain, but when you get high impact, it jostles everything inside, which is not really cool. And of course, that's become a major problem with the battlefield injuries of today as opposed to the battlefield injuries of World War II, because there's so many people that get this incredible concussion from IEDs blowing up under their Jeeps and all that kind of stuff that leads to basically very severe brain injuries, traumatic TBIs, traumatic brain injuries. So anyway, you need to know this anatomy, you need to know what the function of each of these 6 parts of the brain is, and the other important point to remember is that as we go from the spinal cord to the medulla, all the way up to the top of the brain, to the cerebrum, the processes and complexity of the information processed by that part of the brain gets more and more complex. Till you get to the brain, the real brain, the cerebrum, which does your thinking and memory for you up at the very top. So it's all a progression going from bottom to top. Your spinal cord does not think for you. There are a few reflexes set up in the spinal cord, but that's it. They're just automatic reflexes. There's no thought goes on down there. Let's talk about the layers around the brain that give the brain protection. First of all, the most important protective device that we have is we have this box. That's what I always call it, the box, which consists of the skull, and it's a rigid box, which is good because we can get hit in the side of the head and it doesn't rip our brain up usually. So the bones are the most important thing. Now there's good and bad with everything. The good part is the bones protect us. The bad part is that if our brain swells any inside of the box, it has nowhere to swell to. And as a result, when it starts to swell, the pressure inside the brain goes up, up, up. And that's really damaging to the brain. So oftentimes, neurosurgeons are taking big pieces of the skull off in order to allow the brain to actually swell for a few days. Hopefully it'll go back down, and hopefully they can put that piece of bone back in. But swelling of the brain is a big killer. We have a lot of drugs that we can use to work on swelling of the brain and other mechanisms we can try to lower the pressure in the brain. But the bones, just know that the bones are a good deal, but they're also kind of a bad deal if swelling starts to occur. The cranial meninges, the dura mater, the pia mater, and the arachnoid mater, right? I didn't give them in the right order, I don't think. It's the dura mater on the outside. It's the arachnoid mater, which is the one in the middle. It's spider-like. Arachnoid, get it? Arachnophobia, remember that movie? And then the one inside is the pia mater, which is a little tiny thin layer. And I will tell you that in this class, you will never see the pia mater. Just know that it's the outermost layer of the brain that you see. Now, under the microscope, you can usually see it as a little layer on the outside of the brain, but it's very, very, very thin, and it doesn't really peel off of the brain itself. The dura and the arachnoid, you can see those pretty easily, but the pia, you can't. The third protection process that we have going on in the brain is called the blood-brain barrier. Blood-brain barrier. This is a very difficult concept, I think, for students to understand and for teachers to teach. But think about it like this. Our body can handle lots of variations. We can handle lots of variations in our pH. We can handle lots of variations in our blood sugar level, for example. We can get exhausted and have buildup of different waste products in our system that we haven't cleared off. But our brain won't tolerate any of those. The brain needs to be at perfect homeostatic conditions all the time. And so there is this system that's set up that surrounds the brain that keeps the concentration of sugar, concentration of sodium, concentration of everything in the brain tissue itself perfect. So even a diabetic who might have a blood sugar of 1200, normal's less than about 100, okay, and a diabetic might have a blood sugar of 1200, the blood sugar inside their brain will be 100. It'll be perfectly normal because of the blood-brain barrier. The blood-brain barrier will keep out all that extra sugar so that the milieu, the chemical makeup of the tissues that the brain is actually working with are always normal. Does that make sense? Another example, back in the day, when we didn't really understand this blood-brain barrier, we had certain drugs that would go in through the blood-brain barrier and get into the brain. And we had other drugs that you could give by the bucket load, and the blood-brain barrier would not let them through, and therefore they didn't do any good. And it took a while for medicine and pharmacy and doctors and so forth to figure that out, because there were some antibiotics that you could use that worked really great on most infections, but they didn't work on brain infections at all. And the reason was because they didn't get through the blood-brain barrier. And I can actually remember, this is back in the day, that neurosurgeons used to drill a hole into the brain and insert the medicines into the brain itself in order to get them through the blood-brain barrier. Now eventually, we got smarter and we developed other drugs that would go through the blood-brain barrier. So now we have a handful of antibiotics that will go into the blood-brain barrier to treat meningitis and things like that. But then we still have others that don't go. And you just know you don't use those on brain infections. Kind of odd, isn't it? Here they are, dura mater, arachnoid, pia. These are continuous with the spinal meninges. So you've already learned these, right? Because they're the three layers that surrounded the spinal cord as well. And indeed, they come right up from the spinal cord and they surround the brain just like they did the spinal cord. They protect the brain from cranial trauma. Sure. They don't work well on bullets, though. Dura mater has two layers. And you need to understand the two layers of the dura. One of them just lines the inside of the bone itself. So it's called the meningeal layer. It's called the endosteal layer. Endosteal. Osteal is bone, right? So right on the inside of the bone, there is this outer layer of dura called the endosteal layer, and you see here it's fused to the periosteum. The inner layer is the meningeal layer, and it extends down into the brain. And an example, if I can draw, of the top of your skull here. So here's the top of your skull. This is the bone, for example. And then here's the outer layer of the dura. And the outer layer of the dura goes like this. And it's really tightly fused here to the inside of the brain. It's the endosteal layer, right? And then the inner layer of the dura kind of goes like this, and it goes all the way down in, for example, the crack between the two, the right brain and the left brain over here. So there's a fold of dura that comes down between the two parts of the brain to keep the brain from sloshing from side to side. But as it does that, it does one other thing that's kind of weird, and that is, let's put this one a little bit more closer to the surface out there. This one too, a little closer to it like that. And this right here becomes a blood vessel. That's called the venous sinus. Now this down through here also fuses. And then it opens up down at the bottom end, and there's another venous sinus down here at the bottom. Now when I say venous sinus, what do you figure that means? Where the blood goes back to after it's percolated through your brain. It goes back into those venous sinuses, and then it collects and eventually goes back to your heart to get pumped around again. So these are big blood veins that occur on this, right on the outside of your brain. That's these venous sinuses between the two layers. I got good pictures of that in just a minute. The arachnoid mater is the one that looks like a spidery kind of thing, covers the brain, contacts the epithelial layer of the dura mater. Below that is, between the arachnoid and the pia. So yeah, below the arachnoid mater is the subarachnoid space. Now, the subarachnoid space is the space that's filled with cerebrospinal fluid. How many of you have ever had a spinal tap, or one of your friends or babies has ever had a spinal tap? Well, if you've had a spinal tap or seen a spinal tap done, it's basically just putting a needle into your lower back between two vertebrae, and you go through the dura, you go through the arachnoid, and you stop, hopefully, before you go into the spinal cord. Although you're below the spinal cord, you're just in that bunch of horse's tail, right? What's that called? What? The cauda equina, yeah. Cauda equina. Horse's tail, right? Okay. So anyway, you go in there, and once you get into the subarachnoid space, then you take the thing that goes down through the middle of the needle, the trocar, and drip, 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 drip. Out should come cerebrospinal fluid, and that cerebrospinal fluid then can be tested for all kinds of things to diagnose all kinds of diseases that might occur in the brain or in the spinal cord. That's a spinal tap. I think they made a movie called that, didn't they? Spinal tap. Anyway, subarachnoid space is the one you need to know because that's the one that you're going to be that you will see tapped many times in your career. I did a spinal tap one time on a baby that was about 6 hours old. They're not that hard, because they let me do it. But spinal taps is a very common medical procedure. You'll see it done in the emergency room from time to time. You'll see it done in the ward, in X-ray, and so forth. The pia mater is that very tiny thin layer that's attached to the brain surface. It's held there by, oh, wait a minute, astrocytes. That's another one of those cells, right? That you didn't think you'd have to remember? Yeah, just remember it. These dural folds are pretty cool. There's 3 of them that you need to know of. One is called the falx cerebri. Falx means the middle, the fault in the middle, okay? The middle of the cerebri. So it's the one that goes down between the 2 major cerebral lobes. It's in the midline. Then there's one called the tentorium cerebelli. And the tentorium cerebelli is like, think of it as the tent. It is the fold of dura that goes in between the cerebrum above and the cerebellum below. So it's the tent over the cerebellum, back there in back, where the cerebellum lives. And then there's another one, this one's really pretty small, called the falx cerebelli. And it goes down the middle, and once again goes in between the 2 lobes of the cerebellum. I think I've said enough about that. Here's another picture of what I was trying to draw up there on the board. Here's the cerebral cortex underneath here. Here's the cranium. Here's the skull out here. Here's one layer of the dura mater called the endosteal layer, which you see illustrated there. And then there's this dural sinus, which is a collection of blood flowing back towards the heart eventually. And then below that is the inner layer of the dura called the meningeal layer of the dura. Below that is the subdural space, and then the arachnoid mater, and then there's the subarachnoid space as well, going around the brain. Wow. This is a really good picture. This, I hope, will help you understand what I was trying to draw and what I've been telling you. Here's that bulk cerebri, it's dura that extends down from the outside, comes all the way down, and here in the middle, it forms another venous sinus there, and then goes back up on the other side. So that's the falx cerebri. This is the falx cerebelli, divides the two lobes of the cerebellum, and then this one across here is called the tentorium cerebelli, which divides the cerebrum above from the cerebellum below. Okay? I think we'll stop right there. I've got a little animation. I'll show it to you next time. Okay? So,